Valency. Objectives: to study valency and valence orbit, tendency of an atom to complete its octet configuration, calculations of valency of an atom and an ion. According to Niels Bohr, electrons in an atom are arranged in a region around the nucleus called energy levels, orbits or shells. These orbits are represented by letters such as K, L, M, or by numbers 1, 2, 3 and so on. The number of electrons present in the outermost orbit are known as valence electrons, and the outermost orbit is called valence orbit. The maximum number of electrons that can be accommodated in the outermost orbit is 8. Elements with completely filled outermost orbit containing 8 electrons are said to possess an octet configuration. Such elements do not combine with other elements easily and hence show very little reactivity. Therefore, they are said to have zero combining capacity. On the other hand, elements with incompletely filled valence orbits have a tendency to complete their octet configuration by combining with atoms of the same or different kind. This capacity of an atom to combine with another atom is called its valency. Elements combine with other elements by losing, gaining, or sharing their electrons. For example, electronic configuration of sodium is 2, 8, 1, and that of chlorine is 2, 8, 7. Sodium finds it easier to lose one electron rather than gaining 7 electrons to complete its octet, while chlorine easily accepts an electron rather than losing 7 electrons to complete its octet. Thus, both sodium and chlorine have a valency of 1 as their combining capacity is 1. On the other hand, consider 2 chlorine atoms having electronic configuration 2, 8, 7 approaching each other. As you can see, each chlorine atom needs 1 electron to complete its octet. In this case, instead of gaining or losing electrons, both the chlorine atoms share 1 electron each. Hence, the valency of chlorine atoms in a chlorine molecule is 1 as their combining capacity is 1. Thus, the number of electrons gained, lost or shared to complete the octet directly tells us about the combining capacity of the element, that is, its valency. Let us now calculate the valency of an atom. We will first study elements having more than 4 valence electrons. Consider an atom of fluorine with atomic number 9 and an electronic configuration of 2, 7. Fluorine thus has 7 valence electrons. In order to calculate its valency, the number of valence electrons are subtracted from 8. Hence, valency of fluorine is 1. For oxygen atom with an atomic number 8 and electronic configuration of 2, 6, its valency is given by 8 minus 6, that is 2. Now we will study those atoms which have less than 4 valence electrons. Consider an atom of sodium with an atomic number 11. It has an electron configuration of 2, 8, 1. Thus, sodium has 1 valence electron. For such atoms, their valencies are equal to the valence electrons. Sodium thus shows a valency of 1. It should be noted that valency of both sodium and fluorine is 1, but sodium loses electron while fluorine gains an electron in order to complete their octets. Hence, valency of sodium is considered to be positive, whereas that of fluorine is negative. Let us now see how the valency of ions is calculated. In case of ions, their valencies are same as the charges carried by them and are expressed with proper signs. Species carrying positive or negative charges are called ions. Those which carry positive charges are known as cations. Some of the simple cations are Na+, Cu2+, Al3+, etc. And hence they have valencies of +1, +2 and +3 respectively. The species carrying negative charges are called anions. Examples of anions are Cl-, O2-, etc., showing valencies of -1 and -2 respectively. Moreover, there exists a group of atoms carrying a charge known as polyatomic ion. For example, NH4+, SO4 2-, PO4 3-, etc. They show valencies of +1, -2 and -3 respectively. Summary. We have studied that the number of electrons present in the outermost orbit are known as valence electrons, and the outermost orbit is called valence orbit. The maximum number of electrons that can be accommodated in the outermost orbit are A. Elements with incompletely filled valence orbit have the tendency to complete their octet configuration by losing, gaining, or sharing their electrons. This capacity of an atom to combine with another atom is called its valency.